Okay, so I want to thank everyone for coming to the first Elixir conference here in Europe, the second Elixir conference in the whole world. I want to thank especially Jim for organizing the event and everyone from the Learning Solutions office, Violeta, Katagena, that helped this event become true. And to me, this event, it's really a special occasion having Elixir conference here in Krakow because I've made a commitment about 5 years ago, and I got married, and I moved, and I'm living here in Krakow already for 5 years. So a lot of my career, development career, and a lot of Elixir, it was built, it happened here in Krakow. So for example, about 5 years ago, I was in this exact room, in this exact stage, giving a talk at Eruco 2010. Was anyone at this event by any chance? Cool. Yeah, so I was here at this stage, and I was giving my first talk at an event in English. It was the first time. The talk at the time was DSL or no DSL. And if you're wondering, like a very quick digest of the talk is no DSL, okay? So, and I hope I won't have to give this talk in an Elixir conference in 2 years or 3 years, okay? So, remember that no right there. And you know, the first commit to Elixir happened while I was living here in Krakow. I like to say that actually living in Krakow is also one of the secrets for me being productive, because when it's winter, I don't leave home, right? So I have those 3 months of like really, I'm not leaving home, so I can do a bunch of interesting stuff. It's a joke, but it's also true, because if you look, I mean, if you go at the GitHub graphs, and for example, when the first commit to Elixir, it was winter, okay? So, and you know, and it was also here, but that I made another commitment. No, I'm not married to all these people. So those are my co-workers at Plataformatec, and I was living here, and then it was over a Skype session, and I told this story at the first Elixir conference in Austin. That at some point, when I kind of had an idea of what I wanted Elixir to be, I've made a Skype with my partners at Plataformatec and saying, hey, you know, I think we can create this language, and we can create something really interesting and exciting. And they obviously bought the idea, right? And I think one of the reasons that we're all really happy to, you know, for having the chance of maybe causing a positive impact in the programming community, and that I think was a lot of the reason and the drive behind us saying yes for allowing me to work on Elixir part-time. That was basically the topic of that discussion, of that call. But the thing is that we are still a company, right? And we had to have some plan, like, of using Elixir in the future, right? I mean, this idea of contributing is great, but as a company, what are the plans? How are we going to use Elixir in the future if we're going to invest on it? And when I left this meeting, right, the commitment was that I was eventually going to do 2 things, okay? So the first one was that we're going to work on Elixir of what I think this could be, on the ideas I had. And one day, eventually, and I missed, like, I gave, like, estimates, and I missed them by 2 years or something like that. So. But I knew that one day I was going to reach Elixir 1.0. And after we got that, we would work on the web infrastructure, in the sense that Plataformatec, we are a web company, right? We build things that run on top of a TCP socket. And we knew that that is what was going to be our use case. But I also knew that it doesn't make sense to make a language that is focused on the web, right? The language needs to be general purpose. And that was actually why, since the beginning of the language, I focused on extensibility, because I knew I wanted to create a language that was general purpose, but it would allow me or my company or whoever would do this work to get this language and extend it naturally okay, to allow us to build this web infrastructure. Okay, so that was one of the ideas behind being extensible, and it's really exciting to see that being extensible paid off, because we are starting to see a lot of interesting use cases. For example, embedded systems. So I just tweeted a video from interviews that we did at Erlang Factory in San Francisco, and one of the interviews that is going to come out is exactly developers. They were able to get Linux, the Erlang VM, and Elixir into an embedded system, and everything booting in 2 seconds. And that's a product, right? They are shipping that, and they are selling that, and they are running that. So that's really exciting. I also heard of cases of people using Elixir in financial and video platforms, like you're doing trading, and it's quite different from what we do at the web infrastructure level, or working with video encoding on the code and decoding on the fly. And also some interesting work happening on the area of graphical user interfaces too. And so this to me is really exciting, because for me, being from the Ruby community, right, and when Francesco asked, a lot of us is from there, so this work for me is like the most exciting work that's happening right now, because it's going to really allow us to broaden our horizons and bring a lot of interesting new ideas, a lot of new interesting thoughts, okay, and I think it's going to be really exciting to see everything play together. So, so talking about extensibility, right, it came from this commitment, and I've I've committed to 2 things, right? And one of those was already delivered, which is Elixir 1.0. Elixir 1.0 came out in September 2014, and it was much bigger than I could ever have imagined, right? By the time it came out, we already had 180 contributors. This is huge. Okay, so thanks everyone for contributing, not only with code, right, but reporting bugs, organizing meetups, trying to convince our courts to have a look at it, right? Everything matters. It's not only the contributors on the code. And by the time Elixir 1.0 came out, we already had 3 books out that were kind of being developed with the language. Okay, so that was really fantastic. And we had, before even the first version, we had the first Elixir conference happening in Austin. So this is really, really great. And I'm, again, positively surprised by everything that's happening on the web infrastructure also, because I always have this mindset that, you know, I made this commitment, and if nobody does it, I will have to go and eventually do it. So I joke with Eric a lot, which is, he's behind the Hacks Package Manager, right? That I'm really thankful that he did it, because I really didn't want to do that, but I knew that if nobody did it, I would eventually have to do it. So thanks a lot, Eric. And the same is happening with the web infrastructure. So Eric again, and he's going to talk about it tomorrow. He's going to talk about Ecto. He started to tackle this database side, right, of the web infrastructure. We need to talk to databases, and Ecto is one of the projects that can do it. Chris, he had this fantastic idea of channels and brought them into Phoenix. And it was nice that he invited me to be part of the framework too, so we could build the rest of this stuff together. I've heard that there are books coming out soon exactly on this general web infrastructure. So that's really good news. And that's because this tooling here, right, they're getting close to 1.0, okay? So there's a bunch of exciting things happening here. And it means that I am getting close, right, to get those 2 things that I promised to deliver them. And this is already exciting in its own, because it's the biggest project that I've ever been involved from, from the beginning, having an idea, doing a proposal, and working. Since that proposal, it has been 3.5 years, right? So it's a huge project, and it has been the biggest project I have ever been involved. So it's really nice to get to this point and say like, hey, this is done. But what excites me the most about this is that when those things are delivered, I can go back to Elixir and focus on Elixir full time again and think, what is coming next. So if you saw my talk at the first Elixir conference or Erlang Factory, I'm always like bouncing some ideas around, trying to get feedback, talking to people. And that's what I want to show for this talk, okay? So what is coming for the future of Elixir, what we can expect. So I've been bouncing those ideas around, and it means at this point I already have a more concrete plan of what those things are going to be. And that's going to be this talk, okay? So let's get started with where we are right now, okay? So right now it's Elixir 1.0, and we had Elixir 1.0.4, we are on the 1.0 branch. So the 1.0.4 was released still this month, it was not long ago. And it was a classic like maintenance release, right? We fixed some bugs. But we actually, when we released these, we decided, based on feedback that we got from the community, we decided to backport some things that were implemented for the upcoming 1.1 version, but we got a lot of feedback and we decided to backport. And those things are, and I'm going to go into details, okay? So with this new version, right, with 1.0.4, we do automatic protocol consolidation. We added 2 new options, one called build embedded and the other start permanent. And what we also added is that this version runs on the latest Erlang and also the release candidate for Erlang 18. So the last bullet here is runs on Erlang 17.5 and 18.0, the release candidate one. And I'm going to go through those 3 main points here, just so you have an idea of what changed and why it matters. So before we talk about protocol consolidation, we need to talk about protocol dispatch. So imagine we wrote this code, okay? I defined a JSON protocol, and I defined the contract, right? Like if you want to implement this protocol, you need to implement the encode function. And what Elixir is doing here behind the scenes is that this code here is going to become this code. Okay, so the protocol is actually a module, and each function that we define for the protocol, we define an implementation. And the implementation at this point is really straightforward. So the encode function, we call JSON encode, passing an item. We need to find the implementation of the protocol for this item. And then we call encode on the implementation, passing the item again. So that's literally the translation that happens at this point. And that's because the bulk of the logic is exactly on the implementation for function. So if we go to the next slide, this implementation for function is going to have a bunch of clauses. So here, for example, is the clause for lists. So if it happens that my item is a list, I need to find the implementation for list. And then the implementation for list is the name of the protocol concatenated to list. Okay, so that's going to give me JSON.list. And because we can load code anytime in the Erlang virtual machine and even more in development, I need to check if the code for this implementation, for this module, if it's actually available. So if we have the code, I'm going to return it. Otherwise, I want to fail that there's no implementation for this thing. Okay? And the trouble with this, and the reason why we need protocol consolidation is because if you are calling a protocol, this is a good amount of overhead, right, for something that we can potentially call a lot. And while this is fine for development, because it's development, it's often not good for production, right? We want production to run as fast as it can. We don't want to be spending CPU cycles, concatenating module names, or checking if stuff is loaded. And that's usually how it happens, okay? So what we do is that in order to be fast in production, we have this thing called protocol consolidation, because when you deploy to production, you're no longer loading code dynamically, right? What you want, what you're going to deploy, your code, your system is complete. So what we do is that with protocol consolidation, we look at all your code, and we look at all the protocols and all the implementations, and we generate much cleaner code for this, okay? So here, after protocol consolidation, we check that the implementation of the item for list, if it's a list, because we saw that there was a JSON.list implementation, we just returned it directly, right? All that overhead we just saw, gone, disappeared, okay? And then, oh, if someone implemented JSON user, right, which is the implementation of the JSON protocol for a user struct, bam, it's here, right? There's no overhead, there's no checking, there's no concatenation, and then we would have a bunch of those clauses, and then for everything else, they were not implemented, so we just raise, okay? So this is much clearer, this is going to be much faster. So protocol consolidation is not a new feature, okay? It's there since before we know, but the issue we had with it is that the protocol consolidation was done manually. You have to call, if you want a protocol consolidation, that you have to call mixed compile protocols, right? And if it's done manually, it basically means that it's not going to be invoked, okay? So what we did with this release is just to automatically consolidate protocols if the build embedded option is true, okay? So I recommend everyone, if you're not running yet on the latest Elixir, go, because this feature on its own is already worth it, okay? So, and you're going to see that if you create a new application, the build embedded option is going to be true if your environment is production. It's exactly the behavior that we want. Cool. Not only that, build embedded automatically does protocol consolidation, but what it also does is that it puts everything into a package, right? So when build embedded is false, what happens is that, so every time you compile your Elixir code, your Elixir project, we generate an underscore build directory per environment. So one for dev, one for test, another for production, and all of your code is there. But when you have a development environment, we use a lot of symlinks because we don't want to be copying like bin files or artifacts all the time, right? So we just use symlinks and that's going to be faster. But again, for production, you don't care about the symlinks, right? You don't want to go through symlinks, you don't want to go through hops. So what build embedded true does is that it's going to get rid of the symlinks, right? And embed everything into the build directory. That's why it's build embedded. So when build embedded is true, we saw that it enables protocol consolidation. But not only that, it packages your whole application into the underscore build directory, and there are no symlinks and so on. Okay? And this is the first step of eventually having releases a more integrated part of Elixir. Right? So if our code is already all in one place, we can start playing more and more of those ideas. So that was the other option, right? Build embedded, and you want it to be true for production. And the final option, which again you want to be true, you want it to be set to true for production, is start permanent. So start permanent is the easiest to explain of all of them. Is that it shuts the node down if our application crashes. So if you have your application running and, for example, the supervision tree crashes a good amount of times, the application is going to shut down, right? Your code, your application. But if we don't set start permanent to true, the application would shut down, but the Erlang node would continue running, which meant that your operating system wouldn't notice and wouldn't restart it, unless you are checking on a port or doing something specific. The start permanent just ensures that when it's true and your application crashes, the node is going to crash too. So whatever you're using for monitoring can see that. And again, we just want it to be true for production, right? Because if you're testing your code and your application crashes, you don't want to shut down the node. You still want the test to finish and give you a nice report on everything. So that's the current state, okay? And I hope that this was the last Elixir release under the 1.0 branch. If we need to do another release, it's not a problem. The release process is really straightforward. It takes like 10, 15 minutes to do it all. But I really want to focus on Elixir 1.1 and 4. And Elixir 1.1 is already well developed. We already have a couple interesting things there. So the biggest one is that the access protocol is gone. Okay, so what is the access protocol? Every time you use the syntax, like you have an option and you do a bracket and a key, behind the scenes, it's calling the access protocol. So just to be clear, this syntax is still going to work, right? They're not changing these, they're not moving these. Just that behind the scenes, they use the access protocol, but we have now changed it to only to do a dict lookup instead. And the reason for that is that I said that the protocol dispatch is usually okay for development, but we found out that to not be the case for the access protocol because this syntax is extremely common. So we ended up calling the protocol just too many times. And if you remember on that slide, right, we had the, I can go back here. We had the code ensure loaded. Every time you call this, it goes through a process called code server, and it could become a bottleneck if I have like multiple processes calling access protocol. So we found out this to be an issue just with the access protocol. We did benchmarkings and testing, and we saw that everything else was fine. Okay, So that's why we are changing the inner behavior, and our code is mostly supposed not to be affected by it at all. That this is going to call directly the dict module instead of going through the access protocol. Okay, so that's one of the changes that is coming, and it's basically to ensure we're not going to have slowdowns in development or test. In production, it doesn't matter. We are consolidating, so it's going to be fast anyway. Okay. The other thing that's coming with 1.1 is that we have many more utility functions in the num and dict. So, for example, we have random in the num. Okay. In dict, it incorporated the functions from the access protocol. We had ways of lazily getting values. So there are some nice improvements here. One very nice feature, and it was contributed by Alexei, that's here, is map set. So in Elixir we have sets, and one of the implementation of sets called hash set. But Erlang introduced in the 17th version, they introduced maps. And with the new version, Erlang 18, that's coming this year, we have maps can now support hundreds of thousands of values. So we decided to try a map set implementation, which is basically a set using a hash behind the scenes. And map sets much faster than hash set. So that's really good news. It means that if you get your code, you'll be able to replace hash set by a map set, and it's going to just work and it's going to be faster. So it's really no effort to get better performance. And the last one is better mix and rebar integration. So if you have a rebar dependency, we automatically compile it and so on. But now that Elixir started to gain a lot of traction, even in the Erlang community, what started to happen is that we have rebar packages, right? That they also have instructions to be compiled with mix. So if that's the case, mix is going to respect that. So even if you have a rebar dependency, if that dependency says hey, I want to be compiled with mix and use the Elixir tooling, it's going to work. And that means we are going to have faster compilation and things like that. So it's a good change. Okay, so that's kind of a good skeleton of what is coming with Elixir 1.1. But all those things here, they were not planned. They came from feedback and from developers contributing. We have actually just one thing planned for Elixir 1.1, which is to improve archives and these scripts. It was one of the things, so Joe in his talk, he said hey, I wanted to do this thing and it's kind of clunky. And then in my reply, the one that he didn't edit, I said, this thing we are planning for the next Elixir release, okay? So what is this feature? So in Elixir, so this works today. We have this idea of archives, and archives are compiled code that you can put in your machine. They are global, and every time you run mix, this code is there, is available. So that's how Hex is installed on your machine. It uses archives, okay? What I want to do with the new Elixir version is to make it easier to install those archives. Phoenix New, for example, now it's an archive. So we want to make it easier. So if you want to say, hey, I want to install an archive from this Hex package or this Hex package with this version, that's going to be supported in Elixir 1.1. And the same from a Git repository, right? If you want to install an archive from a Git repository, it's going to do that. And what this is going to do is that it's going to fetch the project from whatever you give to it. It's going to compile it, it's going to build the archive, and it's going to install it on your machine. Okay? So that's good. That's going to make some workflows much easier. But archives are not ideal because every time you run mix, those archives are loaded. And it means that, for example, you can't put Phoenix or Ecto as an archive because the version in the archive is going to conflict with the version in the project. So archives, they're useful just as one-off projects, okay? If you want to do Phoenix New or Hex, or you want to extend the mix by adding new tasks that it matters only to you, those are good use cases for archives. But to support those other use cases, we want to allow eScripts. And in eScript, you actually get while with archives you compile the code and you distribute kind of in a zip file, With eScript, we get all our code and we can actually put on something that can be executed, right, as a script. And we are going to embed Elixir, and we are going to embed as much as we can. So that's why I want to bring the same features to eScript. If I want to install an eScript or from build one from a Hex package or install from Git, we'll be able to do that. So for example, a very good use case for this is you could have Acto as an eScript, and then you can run your migrations from the eScript. You don't need to have mix on your release or something like that. Okay, so those are the planned improvements, and we are working on them. And that's pretty much it for Elixir 1.1. And I think July 2015 this year, July this year is a good estimate for having it out. I didn't want to put dates, but I knew it was going to be the first question. So I think this is a good estimate for us to work with. Okay? And after Elixir 1.1, we are going to have Elixir 1.2, basic math. And there isn't much planned for Elixir 1.2. What we want to do with Elixir 1.2 is that we just want to bring it up to date with Erlang 18. So right now, we are running our software on Erlang 17, right? But they already announced Erlang 18, and it has a bunch of nice improvements. And Elixir 1.2 is about catching up with those improvements. And the reason why we are doing that, I was discussing with Eric to see if that's really a good path, and I would love some feedback, is because what we want to say is that if you depend on your project, because you can say which Elixir version you depend, if you say, hey, I want to use Elixir 1. I depend on Elixir 1.1, that's going to mean that you support Erlang 17 and Erlang 18 plus. Okay, basically 17 plus. So if you're saying that you support this Elixir version, you're not supposed to use any of the new Erlang features because that's your contract. And if you say I depend on Elixir 1.2, that means you want to run on Erlang 18 and later. And the reason we're doing that is because we believe that this is easier than having people depend on two things, than having people say, hey, which Elixir version are you running? Is it the 1.1? So you need to use 1.1 with this. And then, oh, if it's 1.2, it's 18 only. So in order to reduce this problem, we say, well, so if you want to go 17 plus, use Elixir 1.1. And then if you want to use the new features in Erlang, you should depend on Elixir 1.2. So there isn't much planned, and that's to make it easier, right? We're kind of taking the burden, so it can be easy in your projects. You just specify the Elixir version, and you don't really worry about the Erlang version. Okay? And what's going to happen is that Elixir 1.1 and Elixir 1.2, they are probably going to exist for a good while at the same time. So if we need to do a new minor release or tiny release of 1.1, we'll probably do the same for 1.2 if the same issue applies. And you'll be able to pick whatever you're running in production to what makes more sense. So the only things that we're going to add with Elixir 1.2 are the things that exist only in Erlang 18. So, for example, this is a very small addition, but I definitely love it, is we're going to have a function called genServer stop, which basically means that you no longer need to be defining clauses in your genservers to make it stop and so on. So this function is going to be there, and it's going to be able to stop any genserver. We are going to have official support for large maps. So if what you're doing is, so if you want to use maps and put hundreds of thousands of elements on it, that's not going to work on Erlang 17. Okay? So if you want to use maps as your general data structure and put a lot of stuff in there, then you should depend on Elixir 1.2, and that's when you're going to officially support large maps. Okay, so, and that's probably will start changing Elixir to use those maps and so on the internal things, right? It's not going to affect. Everything I'm saying here is supposed to maintain backwards compatibility. Okay, and the only thing that we'll do is that we'll deprecate the hash dict, because now there is no reason to use it anymore. Maps, they're going to be fast, and they solve all use cases more elegantly. We have pattern matching, it's faster, and so on. And being self-deprecated means we're going to, remove them from the guides. We no longer need to talk about them. We are going to play them down the documentations and so on. So they'll exist there behind the scenes for our code to be compatible. And in the future, when Elixir 2.0 comes out, Joe, do you know which year is it going to be Elixir 2.0? From the target strip?
Yeah, 2019.
Okay, so from 2018, hashdig will be definitely gone. And so that's something we have problem 2. And the other one is that we finally have variable maps. So today if you have a variable like key and you want to create a map dynamically, the syntax does not work today. Okay? But with Elixir 1.2, you can create maps like that dynamically. And I think 1 month later, Elixir 1.1, it's a fair commitment because you just need to add support for those things, and we want those things to exist at the same time, so you can cherry pick what makes more sense for our production setup, and so they should come quite together. Okay, so far so good. Cool. So you're going way ahead here, right? So everything I said so far, it's kind of like, you know, I hope you're feeling that I'm confident, because I'm confident, because it has been planned for some point. For a while we have thinking about it, and just now that we're starting to go more under new waters, okay? But again, as I said, we have been thinking about these issues for a long time, and we are going to, before we get to this release and whatever we're going to show next, we are going to have prototypes out and try to get a lot more feedback. So, if you have been following what I'm talking usually at events, I'm talking a lot about collections, okay? I think the idea of collections in Elixir, it's one of the most important ideas that we have in the language, okay? So here's some code. We have widgets, and when we're talking about collections, it means that I can filter those widgets, I can map. So I filter, I want to get the widgets just with the color red. And then I want to map getting the title and the height of the widget. And then I want to put everything into a map, right, to the key value. So what I say about collections is because we don't really care what those widgets are, right? They can be a set, they can be hash set, map set, they can be a list. Okay, we don't really care. And all this is going to work, right? And we don't care about it. And when we're talking about collections, if you go to the literature, we say that here at the top, the widgets, they are our source, okay? That's the thing that we have at the beginning, and we are going to transform it. And in Elixir, being a source means that it implements the durable protocol. And here, the into, at the end, this is our sink. This is where the data, after we transform, right? This is where the data comes to, right? And it needs to implement the collectible protocol. And because we have those protocols, right, what happens is that we can replace our source and our sink here. I can replace, for example, our source by a CSV parser that is parsing the widgets for me. And I can have as a sink my standard output that's just going to print whatever I mapped here before. Okay? And this code is just going to work, right? Because the source can be anything that implements that protocol, and the sink can be anything that implements that protocol. So this is good, but this is not ideal. What is the issue with this code? The issue with this code is that we are doing everything in big chunks, right? So what we do here is that we are first going to parse the whole CSV file. And then after we parse and load the whole CSV file into the memory with the widgets, we are going to filter. Right? And that's the whole, it goes through the whole collection, okay? And then after we filter, we go again through the whole CSV that we parse from the widgets that we filtered, okay, and we map. And then we just started printing it after all those steps are done, okay? Which means that if I have a large CSV file, like 2 gigabytes, I'm going to load more than 2 gigabytes of stuff in memory when they become maps, right? And then we first filter, then we map, and then just after a while, we started seeing those results. We don't want this, okay? So, and those are collections. So what I want to do is that we want kind of like, as soon as I take the first column from the CSV file, I want it to go downstream and be filtered and be mapped and printed, okay? And we already have this today. And to do that, we just need to do 2 changes, right? The first one is just, we take enum out and we replace by string. Okay, so it's the same code, you just replace enum by string. And because the string is lazy, right, it's not doing any computation, it's just expressing those computations, those transformations we want to do. At the end, we need to run our string, okay? Or convert our string to a list or something like that. Here, just running because I'm interested in the side effects. So what's going to happen with this code? It's much better, right? Because as soon as I get the first CSV line, the first CSV entry that I parsed, I'm going to say, hey, should I filter it? If not, if I'm retaining it, if I'm filtering it, if I'm keeping it, I'm going to map it, and then I'm going to already print the standard output. And then I'm going to see the data coming to my screen as it is processed. And they're never going to load this whole 2 gigabytes thing into memory. Okay, so this is really nice, really nice. It's already there today, we can already use it. So when we're talking about collections with laziness, so strings adding laziness, when we're talking about this thing, a little bit of background, it's based on something called Haskell iteratives. And what iteratives gives to us is exactly that our sources and our sinks, they can be in-memory collections and resources like I/O, right? So we had an I/O source. It could be events. So it can be, you can have a stream of data coming from a gen event, or you are connected to, if you're doing financial trading, you can connect to something that is emitting stock values, right? And that can be your source. And then you are getting this data, processing it, and putting it elsewhere. Okay, so we can do that today. However, what we can't do is that all the transformations that we have so far, when you look at string, filter, map, take, all those transformations, they are purely functional. And what I mean by that is that they don't use a state, they don't spawn new processes, they are purely functional, right? There is no side effect happening there. Everything is synced, everything is happening as it comes, right? So this is good because if our code does not have side effects, if our code is pure, it's easier to understand and so on, easier to debug. But it's limited. So far this limitation of everything being purely functional is good because we ensure that our abstraction is good and it's expressive. We can express a bunch of computations, even with this limitation. But what we want to do with Elixir 1.3 is that we'll finally lift this self-imposed limitation. And what this means is that we are going to start to add asynchrony into our string functions. So we're going to have new functions that have this idea of asynchrony. So what does it mean? Give me an example of such function. String merge, okay? So what string merge does is that it can have two sources, okay? For example, one is a gen event string events being emitted by a gen event, and another source could be whatever is coming from my standard input, and I can merge them. And what this does is that it's going to look at the not good way of doing this, that it would be asking, right? Hey, source 1, you have something new, so give it to me. Hey, source 2, you have something new, give it to me, right? So it's going to get data from those two sources and emit as one source at the end, okay? But that's not how we're going to do it, right? We're not going to be pulling. What we want is that we want to have something that as soon as this source has some data, it's going to push to something, right? To a process that knows how to forward these on. So you're going to go into more details, okay, about this and how it works. So something that helps a lot to understand what those functions do. There is a project that came from .NET called the RX project, and it has those fantastic graphics that explain what those operations could do. So what merge does is that, for example, here we have two sources, okay? So here we have a source that is emitting those events, and then here we have another source that is emitting those events, and after you merge, you get a single source. Okay, so, and merge, what it's going to do is that it merges, right? So, as soon as we have the first event here, we can see that it's going to be emitted at the end, right? Through our final source. And then we have another one, then another one. Now I get the first event from this one, and then we have just one source. So, how this can be useful, right? For example, I just gave the example from financial trading. Right? So you can have data coming from different markets, and you want to merge this data coming from different markets and put into a single source and process them as they come. Okay, so that's one very simple example. Another example of functions we could add that have this idea of asynchrony, okay, is M. So what M does is that it has, for example, in this case, it has 3 different sources, and as soon as one of the sources emits an event, I'm going to pick that source as my single source, okay? So here we have like 3 sources, okay? One emitting 20, one starting with 20, another one with 1, another one with 0. But if you look here, the first one to emit an event was the one in the middle. So what we do is that from now we are just going to emit events from our source in the middle, and we discard the events on the other one. So how could this be useful? Imagine, for example, you need to communicate with 2 services. Those 2 services, they give exactly the same data. But you're always you're using 2 services for reliability. If one service is down, you want to get this service from the other. You want the one that is fastest. This allows you to do exactly that, right? You want to connect to 2 services and say, hey, the first one to send me data is the one I want. Because this data is duplicated, I don't care about the others. So the first one that starts giving me data is the one I care about, and it's the one I want to use. Okay? So, and there are a bunch of other functions. So for those that are interested, you can check the RX project. And they have a bunch of those functions and those fantastic graphs. You can actually play around with these, like move the marbles around and so on. So it's really, really nice. So with a couple more examples, right? So let's go back to our stream merge. So here we have this source one, and we have another source, and we want to merge them together. How would we implement this merge function? Okay. Remember that those things are sources. Okay. So I already know how to take values from the source one. So what I could do is that I could say I will create a new process to take the values out from the source one. I will create another process to take the values from the source 2. And then I'll have a process here, right, the one that's doing the merge, just waiting for those events to come from those 2 processes. So here's how this code could look like, very pseudo code, just to have an idea. So I have the merge function, and then I need to get the name of the current process, right? So I'm going to start a task for each source. So here is a task for the source one. And what I do is that I just take the events from the source one, and then I send to the parent, which is the one that's going to be waiting for those events here at the bottom. So I know that some of you cannot see at the bottom of the slide, so what we have here at the bottom is just a receive that is waiting for the events. So for each source, I would start a task, emit the events to the parent, right? And in the parent, I am receiving those things, and I will start emitting them. What this looks like at the end of the day is this. Okay, so here is our initial source. We have source 1, the gen event. The other one is the I/O. We are going to spawn tasks that's going to be getting the events from those sources. Okay, and at the end we're going to merge in our process. Okay? But if we look at it, we say, this is not very efficient, right? Because gen event is a process. It already knows how to send events around. Okay? Why am I making it go through this task that then sends it to merge? Okay? It doesn't, it's like, something's off. So what we are going to add, and we have discussed this for a long while already, is to have a new protocol called the connectable protocol. And what the connectable protocol does is that it tells how one source can send events to another source. So in this case, the gen event, if it implements the connectable protocol, it knows like, oh, you want me to send a message to the parent. Okay, I'm going to do that for you. You don't need to create something intermediate for me. Okay? But if for some reason it doesn't implement the protocol, then we're going to have the intermediary task. And we need the task, for example, if we're working with in-memory collections, right? They don't know how to send messages. So sometimes we need the tasks. But if it implements the connectable protocol, we can start connecting those processes. And we start to see events flowing around or flowing on our system, right? And we can start reacting to those and work on those. So I'm going to, yes, so we're getting there. So what is the connectable protocol? It tells how to connect processes, and it specifies the underlying messages for communication. So when we define the connectable protocol, we are defining how processes, they need to exchange messages between them to have this data flowing through your system. And this is leading us into a direction where we can start to design systems that are are more explicitly event-driven and data-driven, right? We can have data coming in, and we're going to have good abstractions for composing, right? I can map, filter them, which I already do, but I can also now merge them, send them to different sources, and are going to be much more expressive when we are thinking about data or reacting to events that are coming to our system and leave through our system.
Can I take my sensors and Lego and then turn them into streams?
Sorry, can you...
The sensors I have in my Lego, can I turn them into streams and then just connect it like that?
Yes, exactly. So if you change your... yeah. So the question is, if, for example, the Lego application, right? Maybe it has a sensor that is emitting, that's emitting events. You can transform those things into events, right? And then that's the source. You just connect to it and say, hey, I wanted to send this event now to this gen event process, or to this thing that is going to, you could have one process that is just getting, if you're having images, it's just getting those images, processing them, and saving to the operating system. Right? But that's exactly the idea, right? You have events coming to your system, and you're going to have very good, you're going to have very expressive framework for composing and working with those events, right? And so the Collateral Protocol tells how processes, they can connect to each other, and it's going to define exactly how this communication should happen. And as we saw, if our process doesn't know about the Connectable Protocol, it's going to spawn a task for it. So everything is going to be connectable out of the box. So, and that's what we can do with the Connectable Protocol. But the most exciting thing is not that, but is after we define how processes, they should communicate to each other to have this information flow going, it allows us to do a lot of interesting stuff. For example, it enables us to do pipeline parallelism, or it enables us to do easier routing of events from our system. And those are the last, it also enables routing. And those are the last two things we're going to talk about of, of these ideas that we're having for Elixir 0.3. Okay? So let's talk about pipeline parallelism. It's one of my favorite features of this whole story. Okay? So we saw this code, right? We have CSV parse, and we have filter, map, into, and run. And this code, it runs inside one Elixir process. So there's one process that takes the first CSV line, and then we filter, and then we map, and then we print. But let's suppose that of this whole pipeline here of computations, CSV parse is by far the slowest of it. Wouldn't it be nice if I could say, I want one process just to parse the CSV file, and as soon as it gets the first line, it's going to send a message to this other Elixir process that can then filter, map, and print? And that's exactly what we'll be able to do. And to do that, we just need one change. So we have this code. In order to start running the CSV part into another process, we're just going to add stream async. Okay? And what stream async does, that's going to get all the computations behind it, right? Which in this case is just the CSV parse, and it's going to run into another process. And because we have defined how those processes communicate, I can have this process doing the CSV parsing and then send the data elsewhere. That's going to do the rest of the computation. Okay? So in this case, with one stream async, I have now two processes executing this pipeline, and if CSV parse is really the slowest part, we are going to already see some performance benefits, right? Our code is going to run faster. The CSV parsing and printing is going to be faster. But not only that, if you have a large pipeline, right, we can insert stream async every time. And every time we insert it, whatever was before, up to the beginning or between the pipelines, it's going to happen in its own process. So we end up with this. Okay, we have like the CSV parsing starts, and then as soon as the first item is available, we send it to this process, and this process starts computing the second item, what here is on the first, and then when this is done, it sends to the next, to the next, to the next, and so on. Okay, so because we have defined this whole foundation, I know that I'm going to the low level, the details. This is the gold chest at the end of the rainbow, right? When we start to be able to do this kind of stuff, right? To say, hey, I can just say I want this to execute in its own process, and then I can have data flowing through my system. I can start to explore more of parallelism. Okay, so this is really, really cool. So that was one of the ideas. And the other idea is that I can also start to think about routers, okay? And here is event router. So what I could do is that, oh, I have those events coming and I know the message, right? So what I can do, for example, is that when it gets to the router is going to take some specific action on it. Which action? For example, it could broadcast for everyone. So if here we have the events 1, 2, and 3, and the router knows how to broadcast, what it does is that it's just going to send the event 1 to everyone, the event 2 goes to everyone 2, and the event 3 goes to everyone 2. That's a broadcast router. But if you want, you can also do round robin, right? So it's a router that's going to send the first event to these, the second to these, the third to these, the fourth to these, and then you start at the top again and you go, okay? You could also do sharding. Okay, this is really interesting. Maybe you are receiving the data and you want data that has some particular name or some particular kind. You want it to go to a particular process, right? Those are all processes. So if you want to do sharding, you can look at the event, the router can look at the event and say, hey, this event, I know that you want to send to this process. So the event 1 goes to this one. I know that the second comes here. Oops, the third is to the same again, and the fourth, and so on. Or it could be completely random, right? Why not? Let's just randomize and have the events going everywhere. And the way we're going to do this is exactly with this thing called gen router. And a gen router is going to be a OTP, because it's not really an OTP, but it's going to be like any of the other OTP behaviors. What it specifies, we have all the classical callbacks, so I'm going to ignore the ones that we have in the server and everything else. It has 3 callbacks. Handle up, which is every time you get a new connection to the router, so every time someone says, hey router, I'm interested in this stuff, we're going to call handle up. Every time someone disconnects, we call handle down, and then we have handle dispatch, which in handle dispatch what it does is that every time we receive an event, handle dispatch should say to which processes this event should go. So how it works is that handle dispatch is going to return a list of processes that the event should go. So broadcast is the easiest one. I forgot to add the code for broadcast, but if there's time I can even live code it very quick at the beginning just to have an idea. But what it's going to do is that it's just all the PIDs that the router knows, you just return them, and you're going to be able to send, you're going to broadcast for everyone. If you want to do sharding, the event is here, so you can look at the event, look at some property and say, hey, for this property, I want to look at this other one. And the router can also, and the plan is to ship with many routers. So we are going to ship with a router that already does broadcast, because we don't want everyone to be re-implemented all the time. We are likely shipping one that does round robin, but we also want to ship routers that are based on probes. So for example, instead of using any of the things that we said here, I want to send the message to the process that has the smaller message queue, right? Because if they're all doing work, if I know which is the one that's less busy, that's the one where I want to send. I want the route to send the event to, right? And eventually plan for overload. If I want to be able, if I can, I want to be able to say all the processes are busy. Okay, so don't mind sending data overload, and then you can either think of doing back pressure and making the client fail, or just discard the data, right? Because when we are talking about overload, you need to choose between or you apply back pressure or you start to throw the data out. Otherwise, your system is going to be forever in overload and start to draw. But the router is going to be a pattern that's really going to enable us to do this. Okay. So what is the path forward, right? I said all those things. I went even, so what I wanted to show here, at some point, I know it became very specific, was the design process, right? We start from the foundations, and then here at the end, we start to see what are the benefits that we start to reap, right? We can come with a routing abstraction that can be very useful. We can start talking about pipeline parallelism and another interesting stuff. So we start with collections, okay, and at some point we added laziness, okay, and this is where we are right now. So we said, let's start adding asynchrony, because asynchrony will make us think about how those processes, they need to communicate and talk to each other. And then asynchronous is already useful, right? Stream merge and stream amp and all those other functions, they're already useful on their own. And we can find interesting use cases for them. But the part department starts to get really excited and we start to say, hey, now I have pipeline parallelism. And this is kind of our focus for 1.3. But it doesn't stop here, because after we do pipeline parallelism, we can think about data parallelism. Okay, like I have the data and I want to send this data around, split around in more interesting ways based on the data itself. We can start talking about distribution. What if I have so much data coming to my system that I need to start sharing it between machines? Okay, so it's a long road, but I think we're going to have a lot of fun in the process. Okay, so that's it. That was what I wanted to share. The plans, so just for recapping, everyone that's running Elixir, go to 1.0.4. We have 1.1 and 1.2 coming out. It's already well-defined, we have a good idea. Feedback is still welcome, right? It's well-defined, but it still can change based on feedback, so let us know about anything there. And then with 1.3, we want to start to go into this direction. I could not have done this talk, or could not have done any of this research if it was not for my company, Plataformatec. So I'm really thankful that we decided to do this decision 3.5 years ago of creating Elixir and working on it. One of the things that and this year we are starting to be even more active as a company with the whole community. So one of the things that we also did is that we launched Elixirator. So if you have not signed up yet, this is a newsletter that tells everything exciting that's happening in the community. And we want to launch a jobs section soon. So if you want to hire Elixir developers, let us know. Please send me an email or just ping Plataformatec. Get in touch, okay? And let us know, and we can discuss, because we want to start shipping who is hiring Elixir developers, so we can give that to the community too, because there are a lot of developers interested in being even more active in the community itself. And that's it. Thank you for the attention, and I hope you're having tons of fun. Thank you. Questions?
Okay, we have a few time minutes for questions. If you have a question, can you come just form a line here? I think we're going to have a few questions, so please come up. First one. Yeah, come up. Everyone again, quick, come on up. Come on up. You have to stand right here to ask a question.
How far are you currently on the work with 1.3 or with this reactive part?
So how far we're on the work, it's a lot of Google documents, not so good prototypes. That's the stage we are in now. So I don't have anything to show and to allow people to play with it. But the plan is obviously to get there before and allow the community to play with it, right? It's not going to be surprised like, hey, it's there now, we release. There is going to be a good period for us to get feedback and people to run it into production too and run their system, because that's the most important part. We need to also get production feedback into this stuff.
All this stuff you told about data parallelism and pipeline parallelism, this reminds me of MapReduce and Hadoop in a way. So, any comments on that?
Yeah, so so one of the things, it comes back to MapReduce, and we're probably going to have MapReduce related operations at some point. And it doesn't get a lot from Hadoop because Hadoop is its own beast, but we are looking a lot at what Spark does and what Storm does and bringing ideas from there. One of the biggest challenges, I didn't enter into detail here, but yeah, let me go back, it doesn't hurt. One of the biggest challenges in all of this, and it's mostly what is holding this back, is how to do back pressure. Okay, so remember when I said that when we had that first pipeline, let me roll back more, okay. Where's my mouse? Somewhere. Okay, so remember when I said this whole pipeline, that we never load the whole CSV file into memory? We have one by one, okay? Imagine that what we thought was wrong, that the CSV part is not the slow part, the CSV is actually fast. So if you have this thing parsing the CSV file and sending data faster than this other part can consume, what is going to happen is that at some point, if this is very slow, we are going to end up loading again the whole CSV file into memory. Okay, and so we need to think a lot about back pressure and how we'll be able to handle this stuff. How we'll be able to say, hey, slow down, or hey, start throwing some data out because I cannot handle all this. And a lot of the inspirations come exactly from projects that were born kind of out of the Hadoop group, right? Like Storm, Spark, and so on. Yeah, very good question, thank you. More questions? I think nobody wants to stand up, Jim.
You know the rules.
Mine's related to that, so I don't know whether. So, given what you've just said about the back pressure, what's the overhead of doing that? So, why would you not want to make that a default behavior rather than something you explicitly require?
So, what is the overhead? So, if you can do it really, really fast, you're going to have this overhead of passing messages around and creating new processes, and then you don't want it, right? So, so a lot of these will require you experimenting and finding out where is the place that is worth splitting. If you have like a small collection, if you have a CSV file with 10K, you don't need to spawn this pipeline, right? If you have just shorter events. So that's one of the things, right? If I have just something small, just write the code, don't introduce any of this complexity, because it's not worth it. But at the moment you start to have large things, or infinite things, right? Because if you're receiving data from I gave the example of the stock market, that's infinite, right? You're going to, you know, if they're running Erlang, they're going to be running for centuries. And if you're running Erlang in Elixir, you're also going to be running for centuries. And it's never going to stop. So you will also want to start thinking about this because it's data coming all the time. And this is where it's works. So it's kind of, it's as I showed in the progression, right? It's the next step. So you start with collections. If that's fine, good. Then you go to laziness. If that's fine, sorry. You start with collections. If that's fine, stay in collections. Don't even introduce laziness. But then introduce laziness, and that's fine, stay at laziness. We say, wait, laziness is not enough. Then you start going down. And I think that's one of the exciting things, because the Elixir and the Erlang platform is one of the few where we can start from the collections and go step by step until we eventually get to distribution, right? And it's the same code, you're just, your code is growing a little bit with you as your load grows or your application grows. So that's nice.
So Scale, you know Scale from the Paraphrase project. It's
yes.
Erlang, essentially this things. And so the question is there a way to take advantage of it since it's it's like EU funded? There's lots of people doing it, and obviously want Elixir and Erlang to play well together. But at the same time, there's no like protocols and everything. So
yeah. So there's the Skeleton project that was a research project. And so it's the part I didn't talk in this talk because they had a little bit of pipeline parallelism, but their main focus was data parallelism, and we haven't entered into there. But there is a whole other set of features in discussion where you're saying, I have this data, and what is the best way to spread this data around and compute something really fast. So we can probably borrow a lot of the ideas. I don't think we can use their implementation in any way. Like, because they don't have protocols, they're not going to be talking the connectable thing we talk, but looking at the algorithms and finding out what makes sense, we can definitely do that.
That was really good. Is there any plans to make that work across nodes? So that you can have async nodes work in parallel like that? So,
the question is when distribution comes on this path, and it's not shown here on purpose, because it's way, it's down the line, right? We'll eventually get there. So what you can do today, when it comes to distribution, and want to start doing things cross nodes, you can do what we do today with, because you still can have a Agile server and run it across nodes and send messages, right? That still works. Those are like higher level abstractions. The low level abstractions are already there. And what Elixir helps is that we also have the task supervisor. So if you just want to run something, if you check like the task documentation, we already have this way to say, hey, I want you to run this task in this other machine. And that's what we are right now. And I don't think that's going to change soon because we need to go through this road first, and then we'll start thinking about that particular point. Cool, one more.
Yeah, it's very interesting to see how Elixir is going to tackle kind of big data problems. How do you think will have the Internet of Things an impact on Elixir, like you know, distributed architecture and data from maybe billions of devices?
Yeah, so that's a very good question. I think that the Internet of Things can actually be a very good example because we can just be connected to all. So we already know that the Erlang virtual machine can handle you know, hundreds of thousands of connections or millions of connections, right? So you can think how this fits, and Torben, when he asked about the Lego, it already gives an idea. So what is coming from, if you want, you can treat what is coming from those devices, right, exactly as a event stream, right? They are events entering into your system, and there is a chance that you likely want to merge all of them, right, into a single thing. Right? And you can think like, oh, and at some point I want to route. I have different sources, so from this data coming, I want to send to one process that's going to log statistics about the data because I want to know how frequent the devices are connecting, how frequent they send stuff. But it needs eventually to go at somewhere that is, maybe the device needs a reply, needs some input, so it needs to go to other stuff. So I think it fits well with this idea of, you know, have many things, have a bunch of sources of data come into the system. And if it works well, if it plays out well, it hopefully is going to fit the ecosystem of what you have of handling a bunch of connections really well. So that's my hope. Cool. Joe?
Any last questions? Is this future Joe or current Joe?
I keep saying that CPU power's free, memory's free, but moving data costs energy. Your pipelines are moving data through the pipeline. Couldn't you think of keeping the data in the same place and moving the computation through the pipeline? So that you keep the data still and you move the computation. I mean, imagine you've got a data center, you're going to shift a terabyte of data to the data center, and at the data center there's a 100 kilobyte program. It actually makes more sense to move the 100 kilobyte program to the data rather than doing it the other way around, because you use a lot less energy.
Yeah.
So can you be thinking about moving the computation rather than the data?
So that's a very good point, and I think the projects Spark and Storm, they are exploring exactly this part, like if you can send less data around, or not even that, how you can find, because sometimes there is no way you need to send data around, so how you can find the best topology for a system that minimizes data going around, because sometimes eventually we want to minimize that. Even locally, right? If you can have everything running, so if you have data in one core, if you can minimize the data going through different cores, and you can use the local cache. So that's definitely, at some point we need to tackle that, right? Because otherwise we won't be competitive, right? People will be able to, they will go elsewhere, they're going to find solutions that are faster and so on. But it is one of the part that, again, it's kind of ahead. We will eventually need to think how to do it. One of the complications is that if you have a bunch of Erlang nodes, it's easy to send data. We can send the code around if they have exactly the same version. And that's one of the complications we can have in this setup. It would be really good if it was easier to, you know, to say, hey, I spawned this node, and those are the computations you're going to do, and I can send the computation when the node starts, because, as I said, the computation is super lightweight compared to the data. And then we can send the data and have sending all the computation and make it easier to send stuff around. So definitely we need to explore that. It's somewhere down the line. My biggest focus here, we are thinking about this stuff, but the biggest focus here is to get the pipeline parallelized, because we first need to start using the cores before we go to the next step.
Hi.
To paraphrase, one achieves perfect design not when there's nothing left to add, but when there's nothing left to remove. Would you like to, or do you secretly plan to, or would you like, are you planning to, or would you secretly like to remove some features of Elixir?
That's a very good question. So right now, so the one I wanted to remove is getting out, which is the access protocol. I cannot think of anything right now. So yeah, so the ones that are going out, I kind of said in the talk because, as I said, I'm probably, as all of us here, we're really excited when we're removing code. So if I'm removing code or code's planned to be removed, I'm going to definitely talk about it. So at this talk we said about the access protocol, it's going to be slowly phased out. And again, respecting backwards compatibility. The hash dict is also going out, all the implementation is maps. But I think those are the two biggest ones. Eric, can you recall anything from our discussions? No. Okay, yeah, so right now our list of things to remove, it's really small, and I think we're able to get rid of those. So those are good news. Cool.
All right, well, thank you very much.
Yeah, thank you.